Today we'll be looking at ratios for volume. So we have here the notes. If the similarity ratio of two similar figures is A to B, in other words, we have two figures, they have a ratio because they're similar, then the ratio of their perimeters is also going to be A to B. So for example, if I have two rectangles, and this one is, let's say, 2 and 3, and this one is 4 and 6, then the ratio, if you set up a ratio of 2 over 4, reduce that equals 1/2. So their similarity ratio is 1 over 2. Their perimeter ratio is also 1 over 2. The ratio of their areas, or surface areas, I can also say, because it's both area related, is A squared over B squared. In other words, their area ratio would be 1 squared is 1 over 2 squared is 4. And finally, the ratio of their volumes is represented by A cubed over B cubed. So 1 cubed is 1, 2 times 2 times 2, 2 cubed is 8. So that would be their volume ratio. So this is how I convert to my ratios. If I have a similarity ratio, then their perimeter ratio stays the same. To find the area ratio, I just square it. And to find the volume ratio, I cube the original ratio. So let's try to fill in this chart here. I want you to pause the video and see what you can fill in on your own. All right, let's see how you did. So if the similarity ratio is 1 to 2, I have to square it to get the surface area. So 1 squared is 1, 2 squared is 4. To find the volume ratio, I cube it. So 1 cubed is 1 times 1 times 1, which is still 1, and 2 cubed is 8. Now, of course, to type in 2 cubed in your calculator, you do 2 up caret 3, which equals 8. Now let's try 3 to 5. So the area ratio will be 3 squared is 9 to 5 squared of 25. The ratio of their volumes will be 3 cubed, which is 27, to 5 cubed, which is 125. Now, I'm giving you their area ratio. I want to go backwards to find the similarity ratio. So the opposite of squaring something is square rooting. So the square root of 49 is 7, and the square root of 81 is 9. Now that I know their similarity ratio, I can find their volume ratio. So 7 cubed is 343. 9 cubed is 729. I always have to start from this one to go here. Finally, I'm given the volume ratio, and I want to be able to find these ratios. So to undo a cube, I have to raise it to the 1/3 power of my calculator. Take the cube root, which is 5 to 8. And then square it here, 25 to 64. So this is how I move around in my ratios. To go from similarity to area, square it. To go from similarity to volume, cube it. To go from area to similarity, square root it. To go from volume to similarity, cube root it. So let's try some out. A marble paperweight shaped like a pyramid weighs 0.15 pounds. How much does a similarly shaped marble paperweight weigh if each dimension is 3 times as large? So weight is a measure of volume. So 0.15, that's the weight, over the new one, which we don't know, equals some ratio. Now, the side ratio is 1 to 3, because it's 3 times as large, and we put the small one on top. So the area ratio would be this square, which is 1 to 9, but I don't care about the area ratio. I want the volume ratio. So 1 cubed is 1, 3 cubed is 27. So here I do 1 over 27. Now I'm going to go ahead and cross multiply. So 0.15 times 27 gives me 4.05 pounds for the bigger pyramid. So the trick here is to set up your first fraction, your first ratio, and then find which one you need. Do you need similarity, area, or volume? In this case, we need a volume, so we cubed it. All right, a shipping company sells 2 types of cartons that are shaped like rectangular prisms. The larger carton has a volume, keyword, of 720. The smaller carton has dimensions that are half the size, so its side ratio is half. We want to know the volume, so I need the volume ratio, which means I need to cube everything. 1 cubed is 1, 2 cubed is 8. So 1/8 equals, let's see, what's bigger, 1 or 8? Well, 8's bigger, and the larger carton is 720, so I'll put that on the bottom next to the 8. Then x on top. Cross multiply, 720 equals 8x, and divide by 8. So the volume of the smaller carton is 90 cubic inches. You might be tempted to say it's half, but we have to find our volume ratio to do that problem. All right, finally, I want you to pause the video and try these 3 problems out and see how you do with them. All right, welcome back here. So we want to know the similarity ratio of a cube. The volume is 729 over 3375. Now that's the volume ratio. Now the first thing I want to do, especially when I have big numbers, is I want to type this fraction into my calculator and hit math enter enter. That'll reduce it for me so I don't have such big numbers. When I do that, I get 27 over 125. Now, this is my volume ratio still. I just reduced it. I need to find my similarity ratio, so I need to take the cube root. The cube root of 27 is 3. The cube root of 125 is 5. Once again, you type in 27 raised to the 1 divided by 3. 125 raised to the 1 divided by 3. So 3 to 5 is B. Not 5 to 3, but 3 to 5. An ice cream carton has a volume of 64 fluid ounces. A second ice cream carton has dimensions that are 3/4. So my similarity ratio is 3 over 4. I want the volume, so I have to cube this. 3 cubed, 27. 4 cubed, 64. So 27 over 64 is my ratio. Now, 64 is the bigger carton because the other one's smaller, so we'll get 64 here and x here. Cross multiply, we get 64x equals 27 times 64, which is 1728. Divide by 64, and we get x equals 27 fluid ounces. Final last one. Find the similarity ratio of a prism with surface area 36 to a similar prism with surface area 225. So once again, since these are pretty big numbers, let's go ahead and type that in our calculator, hit math enter enter, and we get 4 over 25. Now this is the surface area ratio. I want the similarity ratio, so I just take the square root of everything, and I get 2 to 5. Please make sure you do the practice, and thanks for watching.